One, two, three, check. Hello. Thanks for joining me on the talk about the firearm production and what to do next while we put it out. First question at the beginning, how many of you had a production incident, like let's say visible to users in the last, let's say 2 weeks? Okay, you are on a good talk, I guess. First thing, I had an impression when I saw the main theme of that. I see here a production outage and a guy sipping coffee. It's probably a developer who just handed over his build file to the operations and has a weekend. And there is a Mordor behind his back, and he's just sipping coffee. And I can't help myself thinking that this is pretty much similar to this one. You probably know that one. And this is fine. So they look similar to me. And I know I suck at prompt engineering, but yesterday evening I tried to force ChatGPT to generate the mashup of these two. And that's how it looks according to ChatGPT. So this is JDD and this is fine and stuff like that, according to ChatGPT. Okay, so a few words about me. I'm software engineer at Software Mill. I shipped many bugs, systems to production. I'm guilty of causing several production outages in these hands. Brought several systems back to life after production outages as well during my career. And I authored and attended many postmortem sessions and learned tons out of these postmortem sessions. I learned things that I have never thought I will learn, that I will need at some point. But first, what's the postmortem? The term sounds scary, and it actually is, because originally it was like examining a dead body, or it is examining a dead body to figure out the root cause or the reason or the cause of the death. Traditionally, when it was kind of ported to products, to projects, to manufacturing and stuff, it was practice conducted after project completion, no matter whether the project was success or failure, just to figure out what happened, what went well, what went wrong. So our classical retrospective procedure, let's say, that we usually do. Then it was adapted to IT systems, but it was kind of shortcut to use it only on either project failures or production failures. So outages, things that some catastrophic situations that happen on production. But basically, in all these cases, it's basically about learning from failures. We need to examine what happened in order to learn from it, in order to try to prevent from happening it again in the future. So key takeaways, if you just want to leave the talk, so bear with me for just one more slide. Key takeaways that I would like you to take out from this presentation. First one is build a team where it's safe to make a mistake. When you know that, when all the team knows that we are playing in the same team, we are trying to ship value, we are trying to ship the best feature possible. Try to work or try to push or change your culture if you can, culture of your team. For the blameless one, I'll talk about it a bit more later. No finger pointing, no blaming. We are here to ship the system together as a team. There's no single person that is guilty. Every postmortem is giant learning opportunity. Just use it, because as I said, it's like massive learning opportunity. I learned tons of it out of each one that I attended. Don't ignore it. Come prepared. Be kind of meaningful part of, have a meaningful contribution into every single postmortem that you attend. Don't stop on the first found root cause. There's a temptation that when you find the root cause, okay, we are done. We know what happened, and that's it. We know what happened, and that's enough in order to carry on with our daily task. That's not the really good option. Make sure you identify the actions, and make sure that the actions are actionable and they are done. And get the necessary buy-ins from stakeholders so that the action points don't land in the backlog for never, but they are just actually done. And share the knowledge that you learn. Share the knowledge with the other teams, with the other parts of your company, because any other teams may have the same issue, may be vulnerable to the same issue that you just got, and you may save them from that. Okay, so these are the key takeaways. So if you want to leave, just you can leave it now, and I hope you'll take something out of it. Why failures happen? This is the obligatory thing. Have a quote on the presentation. Someone told me it looks a bit wiser. So the only man who never makes a mistake is the man who never does anything, which is actually true. I mean, if you lie in bed for an entire day, there's a really low chance that you fail with something, unless the failure is, you consider the failure your own health or whatever, but you probably don't do anything harmful. And again, that's true because like we fail because we ship stuff. We do things, we experiment, we try to progress, and there's natural thing that if we try to progress, we try new stuff, it's not gonna work on the first try. And this again, yet another quote from Thomas Edison, that he didn't fail 1,000 times, he just found 1,000 ways of the thing, of knowing that the thing that he was trying didn't work. And when failure happens, when we have a production system that is running and suddenly is breaking down, is going bananas, the first critical thing is bring the system back to life. And I think that you should do whatever you can and as fast as you can in order to bring the system back to life. The easiest way is usually, like these days in, let's say, cloud deployments and all that techniques that we have, just throw man at it. Like few months back, we had a situation in a project that there was a marketing campaign that was released, and we didn't know about it as an engineering, and we were not prepared for that, and our system went bananas because there was a sudden spike of loads, like 10 times bigger than the usual that they expect. And we were not prepared for that. And the only thing that we did was to scale everything out as crazy, add more instances of the services, add a few more instances of the database reader nodes, and all that stuff. Just throwing money at it. After a few minutes, we were stable, and it was done. And only after we are trying to figure out what happened and how to prevent it from happening in the future. The thing happened because if you have like gradual load increase, there are autoscalers that can help you with that. But in this case, when you have a sudden spike within a second, it was just a like marketing action that they released. There is no autoscaler that's going to help you. So we had to coordinate it later on to get to know from the marketing. But it was way after we acted on the system. So first thing, bring the system back to life. And a few years back, or several years back when I was way younger, I was really into photography, the analog one back then. I'm that old. I don't know how many of you remember or recognize that guy on the photo. Okay, so this is a famous cardiologist in Poland, Professor Zbigniew Religa, and it's one of his heart transplant surgeries. It was after, I guess the procedure took about 23 hours or something. And he's now sitting, like he brought the system back to life because patient was stable and the operation succeeded. And he was just like, looking at the metrics, at the the apparature and all that stuff to figure out if everything is fine. And this is how I see the teams after fighting critical outages. And you can see the guy in the corner. Like these days, we would say that he's like flipping his TikTok or whatever. I see my kids sometimes like in that position, flipping their smartphones, but he's just exhausted and sleeping in the corner. So this is how most of the teams after critical outages look like, at least how I see it, and I experienced it a few times. And what's most important in this case, I wouldn't advise you or your team to jump into the post-mortem or any other kind of analysis right after you solve the issue. It may sound counterintuitive, but it's good to let the team take a breath, let them soak up what happened, let them process what happened. Maybe someone want to take a rest, maybe someone want to grab a beer, whatever. Just let them space to figure out, to align the things, to know what happened, like subconsciously get it processed. But how long is long enough? Should we wait hours? Should we wait days? Should we wait weeks? Maybe you should do it like in the next year. It's tempting to wait too long, but then you may hear things like that, like, nah, it wasn't a big deal. I mean, we had bigger outages in the future. And funny thing is that Venkat, I guess most of you know Venkat, he just tweeted the thing like that, and this is the thing that I see. I mean, from the outages that I had in the past, I can laugh at the moment because we know what we did, what was wrong, and right now it's kind of a comedy. But it wasn't really a comedy at the moment. We were firefighting on the production. So waiting for too long, from my experience, is like 2 or 3 days is at max, and then you can start working on the postmortem itself. But when should we even try to run the postmortem as an analysis, as a process after the outage? There's a Google SRE book, the SRE book that Google published, and they kind of enumerate several conditions. When there is user visible downtime beyond some agreements, when there's data loss of any kind, when there's a serious on-call intervention that's not in a runbooks, that is not, let's say, usual, when the resolution time of an issue takes longer than expected, when monitoring fails, when the issue was discovered manually, we need to know that we need to harden somehow our procedures, our monitoring. And on the right, you can see the list of postmortems from my last project, my current project, actually. And you may say, the project's running from 2019. Not sure the dates, they are not visible that much. So you may say we have a buggy system. And I wouldn't say it's not true. But what we did, if you had a chance to look at the numbers, there's just a few items at the bottom, the oldest one, and the more in the future, the more towards now, there's more items. That's because we started with the high severity and critical issues at the beginning, and once we got good at it, we started like lowering the severity when we try to run postmortems. So for now, we try maybe not every single outage or not every single thing that didn't went as expected to document, but at least most of it. The ones that we know, there are other teams that may benefit from the knowledge that we have. It's just to have it documented, it's just to learn from it. It's just to have it for other services, other team members, and other situations to be easy to find. So the number of the postmortem schemes doesn't really mean that we have a buggy system or not. If you are just starting out, how many of you had a chance to attend the postmortems in the past? Okay, so less than a half. If you are just starting, if you agreed with the team that, okay, we are going to start with that kind of practice, first brainstorm and agree with the team kind of postmortem contract. It can be written, it can be informal, but don't try as a leader, as a, I don't know, manager, don't try to push some rules to the team. Let them agree on the rules, because we want to know what is expected from us as a team members and what we can expect from the management, from the stakeholders as a team members working on the project itself. We want to agree on that, because without that, it's not gonna fly. Push for the blameless culture, and this is something that I will talk more in a minute. It sounds easy, but it's hard to do. And if you have some, maybe I wouldn't say toxic guy, but the guy who is not really, or the people or the culture in a team, which is not like a real teamwork when we are all trying to deliver stuff and we work as a team. When there's no this blameless part and there's no finger pointing culture, it may be really tricky to implement the postmortems. And really grab a pre-made template. There's tons of templates over the internet. They are good enough at the beginning. It's just like 3 sections and it's good. Whatever you take, don't try to reinvent the wheel at the beginning. Yeah, and a few words about the blameless culture I mentioned. What it is and why it's important. We work in a kind of, it may sound silly, but we are working in a kind of creative profession. We try to invent stuff, we try new ways, we try new tools, we try to deliver new features that we haven't done before, and it requires a safe space to experiment, to make progress. And in order to have that safe space, we don't want to be afraid of making moves. We don't want to be afraid to make mistakes. We don't want to be afraid to experiment. And that blameless culture, if you can get it in our team, in our organization, is a must for creating like healthy analysis and healthy retrospectives of the things that are happening on the projects, because it focuses on why something happened and not what and not whose mistake it was. I mean, we are not forcing, we are not finger pointing that that guy like John made a mistake and it's his fault that we are sitting there in a Friday evening rescuing the production systems. It tries to figure out, okay, we know that he did the mistake, and he already knows that he did a mistake. There's no point. It's not worth, and it's no point in like finger pointing and blaming him for that. We try to focus on why something happened and how we can make it better and how we can prevent from doing it in the past. But again, it's not about not calling the names. We don't want to anonymize that stuff to the point that we don't know. Like in a way, someone pushed the button and we don't know what happened. We want to know because we want to know what happened, who did what, in order to have a full picture of that. But it's not like finger pointing and blaming, like active blaming people. It encourages transparency, because then if you made a mistake, you can admit, okay, I did that, happened. I mean, I'll try to do my best next time. You can fix people. I mean, fixing people is like make them make them in a way that they make no mistakes. But you can fix the processes, and the process in here is the culture, the way that we work. And before postmortem, if we are like this through 2-3 days after the production outage, how should we prepare before attending the postmortem session? First thing is come prepared. Don't try to, if you are invited, if you are involved in the, if your team was involved in the analysis, in the production outage in one way or the other, don't ignore it, don't skip it. Come prepared, collect logs, like everyone on your own. Try to collect logs, correct metrics, traces, missed alerts. Whatever you see suspicious, whatever like caught your attention during or after the incidents, when reviewing the evidences, and get all that with you on a postmortem meeting. Ideally, be able to reproduce the issue. If you have a hypothesis, what went wrong, why it happened, try to reproduce it on your local machine, on any other environment. Ideally, on production. If you know what happened, it may be like in fully controlled environment, like few seconds of an outage, maybe not a big deal, again. But still, you risk that your hypothesis is wrong and you may cause yet another outage. But that's a risk. So yeah, make sure what happened and why it happened. Have your own hypothesis and let yourself be corrected during the meeting, because you may not know everything. There may be other people who know, like who have the other bits of the puzzles, and they may change your picture. And we split the postmortem analysis into 3 parts. The first one is building the timeline, what happened, so that everyone has this alignment of what happened during the incident. The second part is brainstorming why that happened, figuring out the root causes, and the third one is figuring out the action points and kind of actionable items. What can we do in order to prevent the issue from happening in the future? And the first one, building incident timeline, make sure that everybody understands how things unfolded, what happened since the very beginning, since the very first symptoms of the issue, towards the entire resolution, and until the end when the system was back and running again. And it's really important to have everyone on the call, everyone on the meeting, to be on the same page and understand every single step, why that happened, and what happened on that step, who made an action, when the action was made, sometimes even with a second precision or millisecond precision. And the output from that step is just compiled detailed timeline of the entire flow. You may put everything that you had spotted in your analysis, and it's kind of collected from the insights of all the people who are on the meeting, who are involved. The second one, identify the root causes. And how many of you heard about the 5 whys analysis? Okay, some of you. So the 5 whys analysis is the most popular, I would say, root cause analysis way. It works in a way that you ask a question why that thing failed, you give an answer, and then you ask why it happened, why the answer happened, why the thing that was answered happened, and you kind of drill down that root cause. You drill down that path until you find the root cause. But that's one of the options only, and that's not really good in terms of IT systems, in terms of manufacturing systems as well. That's why there is one which is called fishbone diagram. You can see the one on your left. It looks kind of like a fish, let's say. It's also called cause and effects diagram. The 5 whys has this drawback that it focuses on really one root cause. If you start digging deeper, you are just focusing on one topic. And if you start using like kind of first group all the possible areas where the issue might have happened, in this case it's like equipment, supplies, environmental, rules, policies, staff and people, and the other ones that you may have in your project organization, maybe it's like machines, tooling, whatever, and you kind of figure out all the groups. Then within the groups you are trying to identify the root causes, and it gives you a way that you have a wider picture and you have a broader look at the thing that happened, and you may identify more than one root cause. Maybe the one that you identified first with the kind of naive approach was valid, but it was not the only one. So don't focus on the first found root cause. I know that's the easiest one, but try to look broader. And when to stop digging, because we may have like temptation to dig a lot. We should stop digging when we know that the issue is beyond our control. When there's something with a cloud provider that we cannot control, if the thing is too expensive to fix, okay, we know we could fix that, but it takes, I don't know, 1-year project for several teams, and it's not worth doing. We should explicitly acknowledge, okay, there is a risk, but it's not worth fixing at the moment. We take the risk, it may happen again, but we don't have funds, we don't have resources to, and there's no need for fixing it at the moment. So yeah, these two ways, like 5 whys, fishbone diagram. Sometimes there's a third one, tree mapping, but the one on the right. But usually the tree mapping is just rotated fishbone diagram. They are pretty similar in terms and the way they work. And as an example, Space Shuttle Challenger. Several years back, there were like two accidents. First one was the Challenger, and then there was Columbia, I guess. For the Challenger specifically, there was during the launch there was a single O-ring that failed in one of the engines because of the deformation, and with a root cause analysis, they found that the deformation was happened because of the low temperature. And if they used only, let's say, the 5 whys method, they could end up with the fact that, okay, the O-ring was made from the wrong material. Let's next time let's try to use the material that is better, that handles the lower temperatures, and be done with that. But the experts looked at the broader picture. That they started questioning or asking why it was decided to launch. If there were all the checks in place, maybe some checks were missing. Was all the necessary info available before the launch, like when launch was accepted? If they had any available info, if there was something missing, what conditions and what cases were not considered, what was the decisioning process? Maybe there was something wrong in the decisioning process itself, something was not considered, something was missing. And as a result, for the Challenger, they found 9 action points, critical action points identified, and for the Columbia, they found 29 action points identified. So it may look like they are not learning from failures, but they were totally different action points. There's a blog post about that, which is titled "Root Cause is Plural," and it's talking about the fact that about the thing that I just mentioned, that there's usually more than one root cause if you dig deep enough. And it may be worth investigating. Maybe some of these are not worth fixing. Maybe it's beyond our control. Maybe we can accept the risk, but it's good to know them. And third one, if we have the root causes, we know what happened, and we should know pretty much how to fix that. Defining the action items. This is basically the stuff that we do on our retrospective meetings after our sprints, or the practices that we do. But from my experience, the action items on the sprints usually are not actionable. I mean, they are, but they land deeper in the backlog and they are never done. In these cases, because that touches production, that touches making money, that touches real financial losses, that should be action points that are really actionable, meaning that they have reasonable complexity. So it's not like, okay, I don't know, Hibernate failed or Oracle database failed. Let's just remove, like swap Oracle into MySQL server in like 1,000 services company. That's really not reasonable complexity, and you cannot do it really in one sprint or two sprints. So relatively small things, so kind of low-hanging fruits, and that have that you may get a realistic buy-in from stakeholders, so that you may get the budget on the next sprint, next iteration, to do at least some of that stuff. Because if you ask your manager, okay, I mean, your dev team may be happy with removing Oracle and using MS SQL or whatever, Postgres, but you know that your management or your stakeholders or, let's say, engineering manager will not gonna buy it. There's no way you can do it. So try to like be realistic in a way that you create the action items, and assign owners for the action items. Again, I know that after our retrospectives we have the action items that are kind of orphans, but in this case we want to have someone who drives that change, who makes it to completion. That we need to make sure that thing happens, that it's actually fixed at some point. And prefer automation over manual processes. I saw several times that an action items was like 10 steps long procedure, manual procedure, check this, check that, click that button, like switch that flag and whatever. And then an action item was just adding one more step somewhere in between. I guarantee you add like in 4-5 times it will fail again, because someone will miss that in one way or the other. If we try to automate that stuff, we are good. If we don't make mistake in automation. So prefer automation over the manual processes. It may be a bit tedious, it may be a bit more complex than just adding a step to procedure, but it's future-proof. And the action points, all that stuff is like kind of inherits all the traits that we know from again our retrospectives in our iterative processes that we do. Okay, and if we know what to do and how to go through the postmortems, who should be involved on the postmortem? Usually the people who caused the issue, like the team who somehow caused the issue. Again, not blaming, it's just the team that caused the issue. And people who fix the issue, who help fixing the issue, because they know what happened, they know the timeline, they know the details of the thing that happened. You may want to have experts in a given area. If it was a database failure, maybe you have a team or people who are really good at databases, engines, DevOps, SRE, whoever, and they may bring value to the meeting. You may also want to have a product stakeholders, managers. It may sound, again, counterintuitive because it's like purely technical meeting. We are talking about the technical stuff, databases, services, compilations, whatever. So why do we need them? The thing is that if they witness that you are struggling with it, that you are doing your best in order to bring the system back to life, and then trying to figure out what happened, and you have a plan on how to do it, how to fix the issue, how to prevent that from happening in the future, it makes wonders, and it gives you a easier way to get that mythical buy-in from stakeholders to work on at least some of the action items in the next sprint, like immediately in the next sprint. Because if they are kind of disconnected from that, and you go to them with a list of items that are gonna take like half of the sprint, and they'll see that they are not going to deliver business value, but just work on some technical stuff, they may not agree on that. But if they see that you are really trying to fix the system, that you are struggling with the stability of the system, that there is something wrong that we should really need to that we should really fix, it may give you this advantage and may give you this the easier buy-in from them for doing the actual improvements. User-facing or customer-facing people, support, sales, whoever. I haven't attended the session or the project where that was a like financial loss displayed, let's say, or reported what was the financial loss of the outage, the actual financial loss. But I heard about the projects that on each post-mortem there was a report that okay, that incident, production incident, caused like thousands of euros or US dollars of financial loss for the company. It may be kind of paralyzing, so I don't really like that idea. But introducing user or customer-facing people can give you the other perspective, like perspective from the outside. What users saw as an end user from the other side. What was reported when the reports happened, when they started seeing the stuff, and how the outage was kind of seen from the user perspective. They may give you really valuable insights. Maybe not the critical one to the solution itself, but really valuable in terms of the entire analysis and future outages and future improvements as well. Also, if the team gets better at the postmortems and all the analysis and all the practices, you might start like opening the doors to whoever wants to listen. Because again, it's about learning. We want everyone in a team to learn as much as possible. So whoever wants to join is welcome, but I would advise to let them in a listen-only mode. So if they haven't been impacted by that and they are not expert, they don't have a like really strong mandate for taking a voice, I would just invite them in a listen-only mode. Let them learn, but don't let them disrupt the meeting, the procedure. So basically, yeah, what to emphasize and what to pay attention to. So kind of sum up to the stuff that I had. Emphasize to the team that we are here to learn, and we are doing it to learn from failures, not to blame anyone. I know there are people who really don't care about the project itself. They are doing their work and they are good with it, and that's it. But we want to everyone to acknowledge that we are doing it to learn and to make the project better, to harden our production systems. It's not to blame anyone. It's not to look for the guilty ones. We are here to learn, and you will benefit as a person, as a developer, with your skills, and the projects will benefit from that as well. It's a really good aha moment, because the outage means that there was some condition in the system that we didn't know about before, and we want to know what was it, why it happened, what were the conditions that it happened, and so on. And recognize and appreciate the good bits in all the procedures and the stuff that happened. Because I know it's about project failures and it's about production failures, fire outages, and stuff like that. But there are really good bits in there. Someone noticed the outage, someone like kind of connected the dots, someone fixed the issue, someone kind of volunteered for fixing the stuff, for figuring out, doing some tedious analysis of tons of logs or whatever. Appreciate, recognize that you'll make people valued in here and appreciated. It's kind of builds a teamwork spirit in here. And really get the buy-in from stakeholders to work on action items. So the technique I mentioned before, just drag them to the one or two postmortems. They may feel kind of alien on the call while you are talking about the technical stuff, but if they witness the kind of pain that we have, it will be way easier to get the buy-in from them to work on the stuff that we need to work. What to avoid? At the same time, don't put too much pressure on this never happening again, because again, we want to fix the issue in a way that it's not gonna happen. Because if you patch that stuff, We expect that it's not going to happen, but still we may not be able to fix. We may overlook some stuff. The similar issue may still pop up in some time. So don't put too much pressure on never happening again, because again it will paralyze the people, and they may get kind of frustrated if they don't succeed on the first try. Don't treat the postmortem as a just document, artifact, meeting to be in, template to fill in, like yet another meeting. Treat it seriously as a massive learning opportunity, both for you and for the project, for the product that you work on. Don't create overly complex procedures. The thing I mentioned before, adding one more step to procedure doesn't really solve anything. It's just like faking that you fixed something. It will break. It's manual stuff. People do mistakes. And don't focus on very first found root cause, the most obvious one, because there may be a few more, and the other ones may be worth fixing as well as as much as the one that you just found. And what's next? After the postmortem is done, after the production is rescued, system is working fine, postmortem is done. Especially when there was critical thing, seek for review from other people, from the teams that were not impacted, that were not involved. Give them the document, let them read that through, ask them if everything was clear. Maybe you didn't spot as a team. You didn't spot some stuff that they may have some valuable input to the document itself. We do it because again, it's to learn, it's to publish to the people, to the other team members. So it needs to be accessible for them and well understood. Verify action points completion. For each action point, set the deadline or checkpoint to actually verify that it's completed. And be strict with that, because if you allow 1 or 2 action points for 1 or 2 postmortems to be ignored or not done, people will get lazy and they will not do the stuff that they need to do. Have a well-known repository of all the postmortems. So the page that I showed you before, the screenshot that I showed you before, we have it on our Confluence. It's well known. The others well known. It's well tagged. All the postmortems are tagged by, I don't know, Kafka, Postgres, Kubernetes, whatever it is, whatever you have in your project. So it's easy to find by tags. If you want to find, like, new team wants to find all the stuff that happened to Kafka before, they want to search for Kafka tags for the postmortems and go through all of these if they want to kind of harden their own systems and to kind of verify that they have all the cases covered. And also make it live. Kind of public review, tech talks, if you have tech talks in your projects, after the postmortem document is published. Make a tech talk out of it, let the people ask questions about that, explain the stuff, what happened, so that everyone knows, like spread the knowledge in the way you can. War games, if you are brave enough and you can afford that, try to do simulations, maybe on productions, maybe on other environments, sometime after the incident, to actually see that if the action points are not yet fixed, maybe that we know that what should be done. I mean, what was broken, like this kind of this time on purpose, but what was broken, how to fix that. And then when action points are implemented, let's see if the same conditions don't gonna blow up the system again. Make the war games, make the simulations. I heard about teams doing fuck-up nights. So they just get the beer and pizza in the evening and they talk about fuck-ups of each other that they had in the past. There's always plenty of talks about that. I haven't attended one, but I'd like to. By the way, if you are Polish speaking, there's a great podcast of Mariusz Gil, Better Software Design, and there is one of the episodes from a few months back, I guess half of the year ago, with 2 guests, Wojtek Ptak and Jarek Pałka. They've both been there and they have great talks on the conference. And they are talking about their biggest fuck-ups in their careers. And the podcast, usually it lasts, like each episode lasts 1 hour, and this one was like 3.5, and it was really not enough. It's fascinating. I advise you, I recommend you to give it a listen if you haven't yet. So all the, like, it's good to listen about other people fuck ups, and especially Jarek is kind of having great talk in that topic. And yeah, basically the key takeaways again: build a team and a space that you have the ability to make mistakes and no one is blaming you for them, until they are not the same mistakes happening again and again, because there's something wrong with that. No finger pointing, blameless culture is a must in order to have a healthy team and healthy an ability even to have the post-mortem analysis and have it effective. Treat it as a really learning opportunity. You may learn about the things that from totally outside of your domain, outside your technical expertise, that may benefit in the future. Like, you never know when the thing that you have just learned may turn itself valuable. Treat it seriously, come prepared, do your homework, be like a kind of like policeman, try to do the investigation first and have your own version and let yourself be corrected by the other people while compiling the timeline. Don't stop on the first found root cause. Work on getting the buy-in from the stakeholders, because if you identify the root cause, if you identify the action points, but you don't have a space and you don't have the permission and you don't have the budget to work on this, there's nothing changed. I mean, you may have the same outage in a few days, even if you've done the postmortem perfectly. If you cannot fix, if you cannot apply the action points, you are doomed anyway. And share the knowledge that you just learned with a team. Again, tech talks, simulations, blog articles, whatever. There's tons of blog articles from the biggest companies like Google, Facebook, Netflix. They are publishing their postmortems. Sure, there's no details like internal details that they are not allowed to disclose, but the general stuff, they publish really long and really detailed articles about the fuck-ups that they had in their projects. And yeah, failures are okay if we learn from them. Again, this blameless culture. If we experiment, we make mistakes, we learn from them, it's fine. But when the same failure happens again and again and again with the same form, it means that something not working and we don't learn from them as much as we could. Thank you.